Hello everyone, thank you for joining today. My name is Manam and today we're going to be looking at scalars and vectors. So we have a few learning objectives, and that's to define what scalars are and what vectors are, and to understand that all quantities in physics fall under one of two of these categories. So if you're ready, let's get right into it. Okay, so now on the board I have here a few quantities. Now, what is a quantity in physics? Well, that's just something we can measure, which as you'll come to find out very soon throughout your course, that's pretty much everything. So I have here a few examples, and those are distance, mass, energy, speed, displacement, weight, force, velocity, and acceleration. Don't worry if you don't know every single one on here, you will very soon. But now let's have a look at the units that we can actually measure these quantities in. So we know that distance is in meters, as always, and displacement is also in meters. Now, there's going to be a problem here, isn't it? Like, how do we differentiate between distance and displacement? Well, we're going to get onto that very soon, but let's have a look at the remaining quantities as well. So, mass, we use kilograms. Weight is newtons, and you'll see that, oh, I thought that mass and weight were the same thing. Well, again, you'll come to see that that's not really the case either throughout the video too. Then we have energy, which is in joules. We have force, which is in newtons. Now again, you can see there's some confusion now. Weight and force both have the same units. Now we have speed, which is in meters per second, and velocity, which is also in meters per second. So you're starting to see a pattern here of a lot of quantities which share units, but they have different names. Then we also finally have acceleration, which is meters per second or meters per second squared. It doesn't really matter, either way is fine. Okay, so now how do we differentiate between two different units two different quantities which have the same units? Well, that's because they fall into two different categories called scalars and vectors. Now, what's the biggest difference between these two is that vectors have direction associated with them as well. So let's take our distance and displacement example. Say I have a path, right, that a person has to follow from point. So they start here and they end here, right? They go from A to B all the way around. Now, say I had another point along the path called C. Now, the distance from A to C would be this direction, this path all the way around here, right? So because they would have to travel this entire distance to get to C. However, the displacement from A to C, so let's just highlight A to C in blue to show you that that's the path, but the displacement from A to C, let's do that in a different color as well, let's do that in purple, would be in a straight line from A to C. We're looking at the distance in a straight line from one point to another. You often hear that as the crow flies, because birds can fly in a straight line. We humans, we have to go through the roads, we have to do twists and turns, so we usually travel a distance which only has magnitude. So magnitude is how big something is, right? So let's write that down. Scalars only have magnitude. But a vector, it has magnitude as well. So you know how far you're going, but also you know where you're going, what direction you're going. So it has direction and magnitude. Okay, so that's just our simple distance and displacement example right there. Now let's have a look at the remaining one. Now, mass and weight, students often get confused and think that they're the same thing, just different words. We're describing two different things. Our mass is just the magnitude. So how much stuff is actually there, right? So say you were looking at the mass of a person, right? How much stuff actually makes up that person? However, the weight can change. The weight is the force of gravity acting upon mass. So your weight on Earth is not the same weight as your weight on the moon. In fact, you're much lighter on the moon because the gravity on the moon is far less. And so that's why you see in astronauts that they can jump super high, because they don't really weigh that much at all. Or rather, it's associated that when you're in space, you're weightless. That's because there's a very weak force of gravity acting on you there, so your weight decreases. Now, weight always acts downwards. So let's take our person here, right? Just standing. Their mass is what they're made of, but their weight always acts downwards towards the center of whatever planet they're on, and it's usually given the symbol either W for weight or F, right? F for force, because as you can see, weight and force have the same units. So you can think of weight as a type of force. Now let's have a look at energy. Energy in itself is just magnitude, right? You can only think about how much energy there is. A force is really a directed form of energy. That's just a bit of like how you can equate the two. So you don't need to worry too much about that. Now let's have a look at speed. A lot of people again think that speed and velocity talk about the same things. They don't. Your speed is just how fast you've gone. Okay, it's magnitude of your speed. However, velocity is how fast you're going plus where you're going. And that's so whenever we talk about velocity, we always have to give a direction. So if I said v that way, we're running. So let's say we're running at 10 meters per second. We're running at 10 meters per second and we're running northeast. Okay, but a speed would just be, oh, that person is running at 10 meters per second, no direction at all. Now, acceleration, again, acceleration is only a vector because it's we can talk about how fast something's velocity is changing, right? Because that's what acceleration talks about, the change of rate of velocity, right? But you can't really say that they've just accelerated. You need to know where they've accelerated to. And so that's why we get direction and magnitude for acceleration, and so it's a vector. So now you understand the definition for a scalar, a quantity with only magnitude, and the definition for a vector, it's a quantity with direction and magnitude, and you understand some of the quantities that fall under these two groups.